So one good way to try to know the properties of a quadrilateral is to try to learn this family tree. Now, the way the family tree works is that everything on the bottom takes after the things above it, okay? So for instance, a square takes on the properties of a rectangle, a rhombus, a parallelogram, a trapezoid, and a quadrilateral. That's what it means to be on the bottom of the tree, and that's why memorizing the tree is helpful, because it shows you which shapes are the most specific and have the most properties, and which shapes don't have that many properties. So I'm first just going to run through the tree just to kind of get a sense of what defines each shape. So one of the most general titles is a quadrilateral. And a quadrilateral is just a four-sided shape. From there, the four-sided shape of a kite doesn't have many properties, so that's why it's kind of off to a side. A kite has no pair of parallel sides, meaning these sides intersect, no sides are parallel, so that's why it's kind of on the top and off to the side on its own. Now, the next title is a trapezoid. This is going based off of the new definition of a trapezoid. A trapezoid is a shape with at least one pair of parallel sides. So if you have at least one pair of parallel sides, that means you could have one pair of parallel sides, or you could have two pairs of parallel sides. If you have only one pair, you are a trapezoid. A trapezoid has at least one pair of parallel sides. Parallel means that the lines do not intersect. So if you look, we have this line right here, we have this line right here. If these lines were to continue going on forever, this line and this line would eventually intersect. So only this line and this line are parallel with each other. If this was in fact an isosceles trapezoid, then the non-parallel sides, which would be these, would be the same measure. They would be congruent. If not, then it's just a regular trapezoid. If you have two pairs, more specifically than being a trapezoid, you are a parallelogram. Now there's another type of trapezoid. So if you have at least one pair of parallel sides, you could be what is called an isosceles trapezoid. Now, thinking back to isosceles triangles, an isosceles triangle is a shape that had two congruent sides. So likewise, an isosceles trapezoid has one pair of congruent sides. So either the top and the bottom, or the two sides are the ones that are parallel. In an isosceles trapezoid, each pair of base angles are congruent, and the diagonals are congruent. Now, getting a little more specific is the parallelogram. The parallelogram has 5 really important properties. A parallelogram has two pairs of parallel sides, opposite sides that are congruent, opposite angles that are congruent, diagonals that bisect each other, and consecutive angles that sum to 180 degrees. First, we're going to talk about the parallel sides because it has the name parallel in parallelogram. So in a parallelogram, this side is parallel to this side, and this side is parallel to this side. So we have two pairs of parallel sides. Now the opposite sides are also congruent. So for example, if this side were 10 centimeters, this side would have to also be 10 centimeters. If this side were 8 centimeters, this side would also have to be 8 centimeters because the opposite sides are congruent. Now the opposite angles are also congruent. So if this angle is 60 degrees, the angle opposite would also have to be 60 degrees. Now an important property is that consecutive angles sum to 180 degrees. Consecutive means one after the other. So angles one after another have to give you 180. So if this is 60, I can do 180 minus 60 to get this angle, which would be 120. 60, 120, 180. Angles one after another sum to 180. 120 plus 60, 180. Angles one after another, adding to 180. Likewise, this has to be 120. So that the consecutive angles are summing to 180, and so that the opposite angles are congruent. Now the last property of a parallelogram are that the diagonals bisect each other. So if I draw a diagonal line, such as this, and if I draw another diagonal line, such as this, the diagonals bisect each other. Bi means two, sect means to cut in half. If this whole segment was 8, each part is cut in half to 4 and 4. If this whole segment was 12, it's cut in half to 6 and 6. These diagonals are not congruent, but each part is cut into 2 congruent parts. So this is the difference between diagonals being bisected versus diagonals being congruent. These diagonals are not the same measure, but each of their parts are congruent to one another. All the shapes below are parallelograms, okay? So when you look at a rectangle has these properties plus all of these properties plus these properties. A rectangle takes after everything above it. Now, what a rectangle has that a parallelogram does not is that a rectangle has 4 right angles and congruent diagonals. But a rectangle does everything that's over here, plus it does 2 things of its own. So a rectangle has 4 right angles. Each of these angles are 90 degrees, but in a rectangle, the diagonals are congruent. So what that means is, like before, if I have a diagonal, my parts are going to be equal, but it gets a little bit fancier than that now. If this is 4, the other half is 4. But also these have to be 4. Because this diagonal line, which is 8, has to be congruent to this diagonal line. Meaning both diagonals have to be 8. And since both parts are cut in half, each of the bisected portions have to be 4. What a rhombus has that a parallelogram does not is that a rhombus has 4 congruent sides, perpendicular diagonals, and diagonals that bisect the opposite angles, in addition to all the parallelogram properties. So in a rhombus, you have 4 congruent sides. So if this is 5, this is 5, this is 5, and this is 5. The diagonals are perpendicular. So that means if I have this diagonal line, and if I have this diagonal line, we have 90-degree angles everywhere that they intersect. But it does not mean that these diagonals are congruent. And since the square is on the bottom, it takes after each of these properties of what's above it.